Welcome to this episode of Furuno Connections. I'm Eric Kunz, Senior Product Manager.
And I'm Clayton Pattison with Technical Support.
In this episode, we're going to cover the second half of our fishing acoustic package for this 39-foot CV. In the last episode, we talked about the DFF3, which is our deep water sounder that's designed to go out on this boat and look for deep water tuna, and hopefully once we find them, we can chum, bring them up, and use our fish imaging multi-beam sonar to find out where they are in the water column and around us, the DFF3D.
The DFF3D is actually quite impressive. It's a multi-beam sonar with a total beam width of 120 degrees port to starboard, which makes it a very wide beam. Now, in perfect water conditions, with the power that's provided out of that box, it'll reach a depth of about 1,000 feet and would have a cone width of about 600.
All at very high resolution, horizontal resolution. So let's take a look at the DFF3D transducers and the beam widths they provide. One of the great aspects of the DFF3D multi-beam sonar that we've partnered with Airmar to make is the wide angle coverage. And that's really hard to overemphasize because even the large or the wide or the ultra wide transducer single beam is about 40 degrees. With the DFF3D multi-beam, we have higher frequency, but we break out from our competitors because it's a full 120 degree coverage area. And that is just so unbelievable that we can put that kind of technology into a small transducer. We can see 1,000 feet under the boat. And we can break that up into 40 individual 3-degree channels. So that's just individual high resolution coverage that as you're driving along and you spot something on the left side of the boat, circle back and hit it with these more narrow, high power systems, single element systems. So the complementary effect is really hard to overemphasize. And Airmar has helped us with that. How does that internal stabilization that you provide work with the DFF3D?
Yeah, that's a brilliant addition.
Yeah, it's a good question because basically all of these 3D transducers include that stabilizing board inside of their outputs to the sonar. So the sonar can make corrections when the boat's on anchor and moving or just in the wave action. It can make corrections for that so your bottom isn't all choppy.
Yeah,
like
so on the DFF3D, it's so wide that if you have a slight roll of the vessel, that can change where that location is on your chart or as you're watching it. And that compensation of the motion sensor really kind of stabilizes that image. And that's something that most of our competitors don't even do. Yeah. So if you're in rough water with a lot of our competitors' products, not only can't they see very deep, but the image gets totally smeared and washed out. And with the DFF3D, that internal stabilization provides a smooth, stable image or imagery, even regardless of the boat motion. Rough water, calm water, you're going to see what's underneath you.
Yeah, and the advantage of not having to install a third part in order to get that functionality out of it is incredible.
Or it's offsetting it, because one of the things that we've seen is our competitors will say, okay, we have stabilization, but they'll give you an extra sensor. And then you have to measure how far off the center line and how far off the center of gravity that sensor is and put it in. When we put the internal stabilization directly in the transducer, there's nothing to do. Set it and forget it, and it's done. One of the other unbelievable facts of the DFF3D multi-beam sonar is that we can install the elements in a flat bottom transducer as opposed to our competitors that use a more of a correlation comparison system. So this multi-beam uses 8 individual elements that transmit simultaneously across a full 120 degree beam pattern. With our competitors' products, they get the wide beam, but you have to have an exposed transducer that can be knocked off or damaged due to debris in the water, and it also creates drag, and it actually does not work at high speeds because you'll have interference. With this transducer of the DFF3D, you have smooth laminar flow at any speed, so it works at speed as well as in slow or even rough water conditions due to the internal stabilization.
So we do a lot of river fishing as well. You know, we don't just tuna fish here. Salmon is a big part. It's kind of a staple of the West Coast, you know, per se.
Yeah.
Fish in the river. Louis 10 has an awesome salmon fishery in the fall. Fish in the 40 to 60 foot range, I would say, more commonly. Tell me a little bit how the DFF3D will help us there.
Well, the great thing about the DFF3D is that it's a 165 kilohertz system. Normally, our high frequency and low frequency sounders are about 200 and about 50 kilohertz.
Yep.
This is right in the middle. The 200 side limits our depth coverage a little bit, you know, in the down sounders. But the 50 kilohertz can actually pound down a lot deeper than the 200 kilohertz, but you lose a little resolution. That's why we picked 165 for the DFF3D. It gives us multi-beam performance, which spreads out 120 degrees. So when you say 60 to 40 feet depth for fishing, realize that at 120 degree coverage with that DFF3D, even though it's shallow water, we're still looking at about 200 feet off to the sides of the boat. That's huge. So you can spot salmon, and if you're trolling, like a buoy 10 trolling, you can kind of dial the boat in and bring the boat in right where you're watching those marks come in, and put your fish right over the top, put your boat right over the top of those fish. It's amazing. Yet, with the DFF3D at 165 kilohertz, we can still go offshore and still hit 1,000 feet and watch bottom structure and bottom contour and wrecks and, you know, and just
underway too.
Underway, and see that information without any limitation at all. So that's the real beauty of the DFF3D, is that it's targeted right in the center of that frequency band where we can go shallow or deep with really no limitations, and do it at speed with a flat hull transducer on the bottom.
While I'm unpacking the DFF3D for installation, let's go to Tim Moore and Captain Jack down on the Florida Keys and see how they're using the DFF3D to find fish, structure, and wrecks in 500 feet and more depths.
Hey everybody, Tim Moore with Furuno, and today we're out here on the beautiful Florida Keys with Captain Jack Carlson, owner of Two Conchs Charters, and he's going to show us how he uses his DFF3D.
Okay guys, we're over the very popular RV Thunderbolt off Marathon here. It's in 113 feet of water. It's a 188-foot Navy cable layer that was sunk in 1988. I have my 3D screen on the top right-hand corner of my Furuno. The bottom right-hand corner, I got my triple beam unit, and as you can see, the wreck is showing up on the right side. This is going to be the right side of my boat, this is going to be the center, this is going to be the left side, and then this is your normal low frequency sounder.
So Captain Jack, I think I told you this morning when we first met, before we came out here, that I'm from Maryland and we do pretty specific striped bass fishing up in Maryland. Now, I can already see, just being out here for an hour now, how much different the fishing is in the Florida Keys. So what do you like to do with your DFF3D to make it work best for you?
Okay, well Tim, this right here, we're coming over the RV Thunderbolt right now. You can see it marking up very clearly on all the sounders here. This is my 3D sounder, and you can see it come up very high. There's fish all loaded up over it. And anytime that you see this, you can easily hit the screen, new waypoint, and mark it. I mark it with the purple exclamation point, because then it tells me I need to go back there and really take a look in that area. It saves it right there and right over here on my GPS. Okay, so what we have here is a bunch of blackfin tuna up high in the water column. That's going to be 85 feet down. We go over here, hit these guys that are down a little bit lower. That's 409 feet. That's going to be your amberjack. And we're right at 483 feet on the bottom. Right here, what you're seeing, we're on top of the hump right here, and right to our right side, and we're drifting to the east. This is where it's falling off, down a lot deeper. That's going to be 627 feet right there. What's nice right here, you're going to be able to see the range by just looking at the color. Right here where you see the blue, that's 813 feet. Right here where you see the red, you're going to be in 436 feet. Here's the red as the color changes all the way down to blue. And with that DFF3D transducer, you can have a bottom marking up on the 3D, be able to see everything and all the different depths. Very important in this style of fishing.
Hey Tim, I think this fish is going to die of old age.
Oh, you just might. For me.
It's an epic battle right here, brother.
I'm telling you.
It's one-on-one. It ain't going to get any better than this, man. You got the biggest fish of the day so far.
I'm loving it.
I think you're going to hold on to that title.
Well, that was fun, but the reality of fishing just kicked in for me. While Captain Jack did get us on a great school of blackfin tuna, unfortunately, as I was reeling it in, as soon as it got to the side of the boat, a hammerhead decided it wanted my dinner instead.
Well, isn't it amazing how Tim and Jack had that TZ Touch 2 MFD split so that the DFF3 and the DFF3D were shown both at the same time?
Oh, it's impressive.
Covers the entire water column. There's really nowhere for fish to go.
No.
It's amazing.
No, they're
yeah,
hosed.
exactly. Yeah.
Well, while those guys are having all the fun down there in the Keys, we're going to get to the real work.
That's right. I found a good place to mount the DFF3D processor unit underneath the console here. But before I mount it, let's talk about some tips and tricks that are really important. For example, the grounding of the transducer cable into the processor unit is a super important step, and you can't take a shortcut.
No,
so let's take a look at how it's done properly. I'm about to install the transducer cable into the DFF3D processor unit. It's a really important step here that you have to know, and it's kind of a tip and trick, but it's in the installation manual. You just have to basically follow it or else you're going to run into problems. Number one, in the installation materials, there is a piece of conductive tape that's provided. There's also a little eye and the mounting screws, no big deal. But what you basically have to do, and make sure you follow this, is to, number one, cut back some of the outer sheath on this cable. Bring it back so that you, at the minimum, you expose these individual foils and the drain wire that goes around them. You have to wrap those back around and then cover them with the conductive tape and make sure that you get it underneath this clamp in the processor unit. We're going to go underneath there. I'm going to show you how I did it. But I just want to make sure that you follow that. It's a super important step, or you'll get a giant noise spike in the middle of your DFF3D display that is meaningless, except that it's a big noise spike. Okay, so I'm underneath the console of this 39CV right now, and I'm looking at the DFF3D processor unit. You can see how I've got these cables, these individual wires with the individual shield around them, trimmed back, and I've got, most importantly, this one shield wire separated out, and let's find where that is, right here. This guy is the shield wire, okay, and that goes right in amongst these other shields. It's not an insulated wire, it's just a bare wire. That's what you have to trim, and trim all these guys, and then spin that shield wire around. Let's see how it looks when we get done. I've got those wires like that. I'm going to take this piece of conductive tape, put it around here, and then bolt it into the gland, and you'll see how that looks in a second. So here we've got a properly terminated transducer cable. You can see how I have that conductive tape wrapped around the especially that shield wire, and maybe bringing in some of the individual foils, and then pinched in between here. You can just, if that's done right, you can squeeze these right down, right on that clamp, and really kind of get a really good ground there, and good isolation. That's all. Really important step. Put the rest of it back together. By the way, the color codes are on the box, on the lid, which are accurate. And there's a small tool called a Wago pinch tool that you need to find on here. It's right up in the corner when you go to fit. And when you finish, put it back for the next guy in case somebody has to take it apart or do anything inside it again. That's all. Put it back together and you're done. So Clayton, now that we've got the DFF3D processor unit and the transducer cable installed and properly terminated to make sure that that ground is good, or else we'll have a terrible noise spike. It's awful.
Yeah, it's really important.
Yeah, that's an important step. I'm glad we covered that. In fact, now that that's done, all we have to do is turn on the TZ Touch 2 MFDs now that the network connection is made, and they'll automatically recognize the DFF3D. There's nothing to do.
That's it?
Exactly.
Wow.
It's just that simple. So stay tuned for the next episode where we take an in-depth look at the TZ Touch 2 MFDs.
So thanks for watching, and if you like the exciting content that you've seen, click the link below to like the video and subscribe to our YouTube channel so that you'll be the first one to know when we have new content available with new product information and new exciting stuff from Furuno.